to section 2.4. We are essentially starting the proof section of chapter 2. Now, I know, because I get asked every single time, I know some of y'all have heard about proofs. And oftentimes, it's not the best things that you hear about proofs. Proofs, generally, as long as you got some structure to them, are not that bad. And I promise you, we will get the structure. And on top of that, in geometry standards, they are a little bit more straightforward. So, please do not get scared away by proofs, because what a proof is it's doing the math that you already know how to do and just making sure you justify your steps. So that's what we are getting into now. Now, as a result, that means that when it comes to going through our proofs, one of the things that you must do is you must show each step. For those of you who hate showing work, I hate to break it to you, the answer is the work. So you do need to show work in this chapter. Jace, do you not have a notes back from last week? I thought you were here for a little bit. Ken, would you be so kind as to grab this off the printer?
Oh, yeah.
Because I've run out of ones that are printed. Thank you.
Yeah.
Okay. So, today when we go through things, we're going to be starting with just some algebra proofs. So we're going to start off with some basic algebra. I've got a question. 4x minus 5 is equal to 12. I want to solve this. Dylan, where would you tell me to start on solving a problem like that? Yeah, you do.
Plus 5.
Thank you. Yeah, you know this. And so I get 4x is equal to 17. Brenna, what would you tell me to do next? Divide by 4 on both sides. And we would get x is equal to 4.25. Now, when I say that the showing of the work is the steps, what I wrote here is still actually a little bit more work than what you need when it comes to showing work on a proof.
Picture test.
You were not a freshman, so no.
Yes, next hour.
When I talk about showing work being what we're looking for when it comes to this section, that plus 5, this divide by 4, those are not necessary. The steps in something that's a proof like this would be just the 4x minus 5 equals 12 that we started with, 4x equals 17, and the x equals 4.25. So, I'm still not asking for, hopefully, a crazy amount of work. We're just asking for some work. Now, as we go through this process, one of the things that we do in a proof is we not only show our steps, but we show our reasoning as to why we're allowed to do that. And so that's where a lot of properties, many of which you already know, come into play. The addition property of equality. That is this idea that I'm allowed to add 5 to both sides to change this into 4x equals 17. So, the fact that I can add a number to both sides is what that property means. Now, in a proof, we do the actual math on one side, and then on the other side of the proof, because it's two-sided, we say, this is my reasoning. Now, my reasoning would be addition property of equality, and that is not a short thing to write. So we have a way to shorten them all. I call it the symbol, because for some it is an actual symbol. And for addition property of equality, we just write add. Subtraction property of equality. Similar. Can subtract from both sides. Thank you, Mr. Carno.
Who's this for?
Jace. Second one back. S, U, B, and you have to go all the way to the T for subtract because there's something else that starts S, U, B, so we have to specify between them. Multiplication property of equality, also very similar. We can multiply on both sides. M-U-L-T is how we shorten that down. Division property of equality. Page 12. Can divide from both sides. Shorten div, D-I-V. Okay, last couple properties are things we've talked about. They are a little bit more challenging in what we talk about with them. They're not terrible. We've done them many times, but the explanation's just a little more complicated. Substitution property of equality, we've done many, many, many times in this class already. Think back to chapter 1. We have problems that look like this. Actually, I'm gonna make that. We have problems that look like that one. We had ABC where AB was x plus
1 + 7 =
Yes, but that's not the point. Where AB was x plus 1, BC was 7, the full thing was 22, and yes, we would do x plus 1 plus 7 equals 22, and we would solve for x. But then I'd have you do things like find AB. And in order to do that, you would plug in x into the equation after you've solved it. In this case, you would have found that x was 14. Plugging that number in like that is substitution. So plugging a number in for what it's equal to is substitution. Since this also starts with sub, we go all the way to the S on this. Subs. If you just put sub, I don't know if you mean subtract or substitution, and I don't give the benefit of the doubt. Distributive property. This is just that can multiply into parentheses. I shorten distributive property to DIST, distribute. And then a last reminder, when you are solving, you can do things like simplify by combining like terms. Okay. So, here's what these problems are going to look like. They're going to give you an equation to solve. The equation that they give you, you simply call the given information. Call it given. And then each step after that, you do the solving. This one's already solved for you, but you say what they did. How did they go from 3x minus 4 equals 53 and change it into 3x plus 50, or sorry, 3x equals 57?
Because they added 4.
They added 4. They used the addition property of equality. How did they go from 3x equals 57 to x equals 19?
They divided by 3.
They used the division property of equality. These are what these problems are going to look like. Math on one side, reasons on the other. Now, this one did the math for us. This one does not. So, I've got negative 9x plus 3 is equal to 219. Joy, if I want to solve this, where would you tell me to start?
Minus.
You're not Joy.
Sorry. I just love math.
Negative 9x is equal to 216. Now, the original statement, the original thing is given, and then Joy just told me that we're subtracting, so subtract. Kata, what would you tell me to do next on this problem? Yeah, we would end up dividing by the negative 9, which you don't have to write the little divide by negative 9. What does x end up being equal to? Negative 24. And what we did was we divided. Div. Go ahead and flip the page once you've got that. Make a pass, but yes. Don't need the laptop right now. Check.
Making him a pass.
Tristan's making his own pass.
Oh, I thought you said him. He's a good friend for Dalton.
Okay. 2p minus 9 equals 10p minus 17. I want to solve something like this. Garrett, where would you tell me to start on this? Subtract what? Subtract the 2p. Now this is not technically considered combining like terms because they're on opposite sides. I understand what you mean by that. We get negative 9 equals 8p minus 17. What we actually did was subtract. Speaking of which, I left something blank here. Aiden, what's this one supposed to say again? Given. Beautiful. So negative 9 equals 8p minus 17. Aviana, what should I do next?
Add 17.
You got it. Negative 9 plus 17 happens to be 8. 8 equals 8p. We were adding, so add. Jack, what comes next?
Divide by 8.
Divide by 8. Now be very careful when you do this one. This gives me 1 equals p, not p equals 1. That's different. Now, if it has 1 equals p, does that mean p is equal to 1? Yes. Is that the way we typically like it? Do we typically like it variable equals number?
No.
Traditionally, yes. Well, this is not the end of the world. Traditionally, we want this. But that is a separate step. That's a step we haven't actually talked about yet. It's known as the symmetric property. We will get to that, but if you flip around the sides of the equal sign, you are using symmetry, which I shortened down to SYMM. Okay. Question 4. 3 parentheses 2x minus 5 equals negative 21. Charlie, what goes right here? You got it. Mason, I want to solve. What would you tell me to do? Distribute. Distribute is what we're doing. Kenna, when I distribute, what do I get?
6x minus 15 equals negative 21.
Beautiful. Lexi, what comes next? Plus 15. Plus is add. Jace, when I add the 15 to both sides, what do I get?
6 equals -6.
Beautiful. Gabe, what's my last step?
Divide 6.
And what do we end up with?
1.
Be careful.
Oh wait, negative.
There we go. Last two are just a little more complicated and emphasize on some of the things that cause some major issues with solving. First thing is still given. Every single proof, regardless of the proof, will always start with the given. I want to solve something like this. Corey, combine like terms. What am I doing? Which is a simplify step. Combining like terms is a simplify. Now my like terms are the x and the 2x, which is 3x. Still got this plus 6 equal to 3x plus 33. Faith, what should we do next? Subtract. 6 equals 33.
Don't look right. They're not.
Doesn't look right, does it? What's it mean when you get something like 6 equals 33?
No solution.
No solution. You're not going to see a whole lot of no solution, but that is something that can pop up. If it is no solution, there's actually not really a step that goes with it. It just is what it is. Okay. Last problem is the one that causes the biggest issues. Most people do fine with what the first step is.
Simplify?
It's distribute. Lou, you still awake over there? Perfect. Okay. But we have to be careful with our distribution. People generally do fine with this side. 6x plus 15. Is that 10 part of the distribution?
No.
No. What is getting distributed? So, -4. If it's a negative in front of the parenthesis, you need to bring the negative with. So it's minus 4x and minus 28. You have to be careful with that. Dalton, if I'm solving, what would I do next? Solving an equation. What should I do?
The x, so you would plus 4x to 6x.
You can do that next. I'll be honest, it's not the traditional way to do it, but it works. Add. If I do that, I am left with 10 minus 28 equals 10x plus 15. Now, some people instinctively want to, as they're doing that, put the 10 minus 28 together. You can't do them at the same time. Not in a proof. They are separate steps. Can I put the 10 minus 28 together? Yes. What's that called? Combining like terms. But combining like terms isn't something we say in a proof. We call it simplify. I accidentally almost wrote 28. Don't do that. Ta-da, I erased it. Callie.
Yeah.
Now what?
Plus 18. I mean, wait.
Minus 15.
I don't know.
Good catch. Because while you can add the 18, it's going to make life harder on you. 10x is left over here. Negative 18, negative 15 is negative 33. Ella, what comes next? Divide by 10. Jonathan, what will we get when we divide by 10? Not just 3.
Negative 3.
Not just negative 3. There's decimal to it.
3.1.
Negative 3.3
I guessed.
equals x. Colin, do I generally leave them that way?
I mean, you
I can, but traditionally we want
can. Just flip it around.
flip it around. You are right, Jackson. What did we call that though?
Symmetric property.
The symmetric property, SYMM. Did you notice that today looks kind of like algebra?
Yeah.
Yeah, they're called algebra proofs.
Wait, so are geometry proofs even harder?
Geometry proofs are going to look a lot like the questions in chapter 1, where you had to write the equation based on this and then solve.
Can I come in and finish my test today?
No,
Why?
because it's Wednesday,
It's Wednesday.
a day that we don't move around in connections.
It's just Wednesday.
Oh, my name.
Wait. Wednesday's
Okay, now, before I let you loose to work on things, your homework assignment. It is a book assignment, page 92, numbers 3 through 14. One of the things that I see people do on a regular basis with their paper. I know, it's a beautiful piece of paper, right? One thing I regularly see people do is say, okay, if it's 3 through 14, I'm going to do 3, 4, 5, 6, 7, 8, etc. You cannot do that with proofs. Because proofs do need to fit this structure of working downwards and having 2 columns. So do not number your things ahead of time. I'm not saying you can't number them. I'm saying that as you go through and number them, okay, I'm going to start with question 3. I'm going to do all of the math right here. I don't know if that's question 1. It's probably not.
Yeah, I'm gonna start working.
Do the problem, then write your next number. You cannot number ahead of time. If you're numbering ahead of time, you're going to run yourself out of space. You can do 2 columns on the same sheet of paper if you can fit that, but you cannot be writing ahead of time. You're going to have issues.